error in product or multiplication. That's what we are going to see. So we say, let x and now here, what you let, you should be careful with what you let. Don't be misled. So not always that always the exact value is going to be capital X. No, like in this case now, our exact product is small x. So always be careful with what you let. So let x and y be approximated to capital X. And now these are the approximations. These are the exact values. And delta x and delta y as errors made, of course, in approximating them. Remember that error is given by the exact minus the approximate. So now our exact is this. It was approximated to this. Now this is our exact, which was approximated to this, which is giving us that. I know that these are always errors are always very small. That when you multiply two errors, the product is almost approximating to a 0. So the exact product we get x minus y, then the approximate we get also the approximate like that. Note that modulus of this is the same as that, and modulus of this is the same as that, and this is inequality. This one is called our theory in inequalities. As simple as that. So you will see there, up there, in some higher mathematics, even the name that's given to it, you will see the name. Anyway, our error in the product, which is given by E, X, Y, will be given by now the exact product, which is X, Y, minus now the approximate product, which is capital X, capital Y. Now my task is to remove these ones and remain with only approximates. So from here, what is going to happen? I'm going to make now this specific. From here, I note that now this x will be equal to x plus sigma x. And from here, my y will be capital Y plus y. So if I want, I remove these ones here. So you start, if I remove them, now I'll be having my x as x plus sigma x into y plus sigma y minus x y. Now there, we remove the exact values. Why? Because the approximate values are there. So we introduce also approximate values inside, like this. There, we multiply. If you have multiplied properly, this time this will get capital X, capital Y. This time this will get X, sigma Y. Then this time this will get Y, sigma X, then plus sigma X, Y minus X. That, then I think you see this one vanishes. So all we have, and it's that we said this one, because they are very small, we said now, and delta X, delta Y is going to be approximated as 0. So now we shall have X sigma Y plus Y sigma X. Because we said these are very small. Imagine what we mean that they are very small. Imagine multiplying 0.0003. I mean 5 times 0.005. Something we are going to get is going to be very small, close to 0. We'll try that and see. So this is our error in the product. So if we introduce modulus both sides, our Ex will be equal to modulus now of x sigma y plus y x. And we say you can now express this as a sum of separate things. But when you do that, it means that's going to be x sigma y plus y x, as simple as that. Now, if this is equal to this, and this is less or equal to this, it means that even this is going to be less or equal to this, because this is equal to this. So, this and this are the same, but this is less or equal to this. It implies that even this is going to be less or equal to that. So, E x y will be less or equal to as simple as that. Now, this is the maximum you can get, the maximum error you can get. I mean, the error you can get is less or equal to this. If you want now the maximum is when the whole of this is equaling to that, as you see if I put a finger there. So the maximum is when this is equaling to this. So now if I say inner of x, y, max, it's now going to be, here it's like a conclusion, x sigma y plus y sigma x. And so that is our idea. So from there, our absolute error is just as simple as that. Maybe we get the relative error. So, note our absolute error is going to be modulus of x where x and this are the approximate. So then if we want the relative error, we said our relative error is the ratio of the absolute error over the inflection. So we are going to be adding now x delta y plus capital Y delta x. We are dividing with now what we have as our, so it's that we are going to be adding x, y, as simple as that. So what happens there, you see that I told you now this comes in. If you have this, it's the same as that. So it implies that now my x, y is the same as simple as that. So if I bring in now this in there, sorry, this is after. Okay, so this will be now, I have now, we can separate this the same as x. You can even, by the way, if it's a product, you can separate, let us take it like this, over x, y, then plus, this is going to be our capital delta x over capital X, capital Y. Now what happens there is that this one is saying here, is saying that this is the same as that. So meaning I'll be having now x, or the rest of x, or as if you don't want to do a lot of steps, you can just say that this is okay, so we say these are capital P's. Okay, so now if you want to do this separate, you start to say this and this, you can now make it enter the same thing. So we said, remember the modulus, we said A over B is the same as A over modulus of B. And this is the same as A over B. I think so. This one is what they are going to apply here. So if I have this the same as this, if I have this the same as this, if I have this the same as this. Okay, so that's what I'm going to do. So I'm going to say now this is the same as x, y, then plus y, delta x over x, y. And you see that this one vanishes, this one is also vanishing, which will give us now delta y over y plus delta x over x. As simple. So that's going to be our relative error. When I come down to my percentage error, is going to be, you said you get this times 100. You said this relative error times 100. So I'm just abbreviating because, okay. The whole of this multiplied with 100. And so after doing that, life will be easier for you. So that's numbers. Now we are going to see the next which will be errors in division or quotient.